Now it's time for our final session of the day. And throughout today's programme, we've been looking ahead to the future. And now we're going to be looking much, much further ahead to another 50 years plus. And the reason for this is it's NCE's 50th anniversary this year. So as well as looking back at the evolution of the industry since NCE was launched in 1972, we've also been looking ahead to see what the industry might look like in 50 years' time. So here to talk about what the industry might look like in 2080, which is even further ahead, please welcome to the stage 311 Institute Futurist Matthew Griffin.
Thank you very much. That's it. It's always good to see that I get the interesting jobs, right? That's it. It's trying to forecast in the year 2080. Now, I'm the CEO of the 311 Institute. Now, I look at two kinds of futures. I look at the future, which I generally regard as the next 20 years. So that's done with organizations like Samsung, Visa, the American government, G7, so on and so forth. But also look further out, up to 50 years. So this is where we're now starting to stretch that time horizon. Because if you're a sovereign government, you typically care about the future of healthcare, welfare state, education, jobs and skills, infrastructure, energy, all that kind of stuff. So at the moment, basically, I work with a variety of different asset managers. We have about $20 trillion worth of infrastructure under asset. And there are quite a number of asset managers who are worried about their infrastructure, particularly as we start looking forward over the next, say, 10 to 20 years as it relates to climate change. But I'm also working with a variety of different G7 governments on about $3 trillion worth of infrastructure projects. And actually, ironically, when we start having conversations about the future of infrastructure in the United States, things like future of transportation, on the one hand, you would think that the future of transportation, we would talk about mobility, vehicles, those kinds of things. But actually, when we have a look at states like Louisiana and Miami, certainly as we start edging towards 2040, 2050, we start asking, what kind of infrastructure do you need when half of your state is underwater and the roads that you built 30 years ago and spent $300+ billion on are melting and or flooded and or both? So it's quite an interesting challenge sort of going to 2080. But this is the agenda. So what I'm going to do is I'm going to show you basically what the world will look like in 2080, because from an infrastructure perspective, we have to know that, or we have to try to be able to predict it. I'm going to be having conversations about future-ready infrastructure, futuristic infrastructure, which is different. I'm going to be having a conversation about the era of massive organisms. So you can make that, you can make from that what you will, and then where next? Now, this is actually, potentially, the water plant of the future. Now, I do a lot of work in the Middle East, and one of the things that we've actually tabled is when you have a look at advances in synthetic biology and genetic engineering, when you combine jellyfish with mangroves, you end up with almost a perfect water filtration system, which makes today's desalination systems look positively antiquated. Now, when we start having a look at airports, because again, there's a whole host of different things that we can actually cover here. In the future, we're not necessarily going to be talking about just airports. We could be talking about things like this. that technology has already been flight tested 50 times. It's been approved for intercontinental transport by the FAA. Space docks are already starting to be developed around Texas, and the job adverts have already started going out basically for the next iterations of that particular one. So when we start having a look at airports, are we talking about airports or spaceports? Now, when we actually have a look at the trends and technologies basically you're all being subjected to, there are frankly hundreds of mega trends. There are hundreds of exponential technologies. We've been talking about particle accelerators. I can show you particle accelerators basically from SLAC, basically that are fit on a computer chip. We've been talking about hypersonic boring machines, basically or hypertunnels, as you say. Now, when we actually have a look at hypertunnels, ironically, Google basically have been developing a hypersonic boring machine. It fires a hypersonic projectile into the rock, basically, and ends up evaporating the rock. So it doesn't matter, basically, what part of the civil engineering estate, basically, you actually come from. Basically, there are innovations, changes, transformations, and disruptions happening all over the place. And so if you scan the QR code, you can have a look at these. Now, I track over 650 exponential emerging technologies. Typically, basically, we'll be talking in terms of things like artificial intelligence, blockchain, augmented reality, virtual reality, 5G, 6G, and everything else. But by the time we get to the year 2080, frankly, basically, we are talking about communications technologies that are essentially quantum communications technologies like 12G, whatever that ends up being. Now, when we start having a look at some of the technologies that we come through, it's very easy, basically, to talk about the future of infrastructure in 2080 to be 3D printed this, 3D printed that. However, organizations basically like Toyota are already using molecular assemblers, viruses, molecular-sized robots, DNA robots, to make molecular-sized products as well as lithium-ion batteries for the next generation electric vehicles. So when we start having a look and start really pushing the dial basically out to 2080, we don't necessarily talk about 3D or 4D printing. We start talking about something fundamentally different. All these technologies are emerging now. They typically take about 10 to 20 years to start commercializing, if not longer. When we start having a look at artificial intelligence, the artificial intelligences that you're using within your organizations are either deep neural networks or binary. If this, then that. We've already 3D printed artificial intelligences. We've already created artificial intelligences made out of biological DNA that can then do calculations. When we start having a look at compute, we talk about quantum computing really arriving now. We have neuromorphic computing. We've already built the 6th generation of biological computer in both China and the US that is capable of, to quote Ross King at the University of Manchester, potentially being the world's most powerful computers ever, because a DNA-based computer that could fill half a test tube would match all of the computing power on the planet that we have today. And if it has a problem, it scales itself up and scales itself back down. We have liquid computers on the table as well. We've already created liquid computer chips, liquid storage, and so on and so forth. I can show you these in the labs. Science fiction is dead. Because we kind of go round this wheel, we combine all of these things together, and this is your next generation product or service. From an artificial intelligence perspective, by about 2050, we should hit artificial superintelligence. It is fundamentally different to the narrow artificial intelligences that you are using today. From a materials perspective, an electronics perspective, we have biological electronics coming through, self-healing, self-replicating electronics coming through. The world that you think you live in is not the world that you actually live in. When we have a look at materials, we have living materials. We have auto-cannibalistic materials, basically, that are essentially programmable. They take different parts of their own matter and then recombine them to create a different shape or form. And we go round and round the wheel. And then we have neural interfaces, which companies like Arup like talking about, basically because they want to use neural interfaces to control drone robotics on construction sites, which is cute. And I can hack a neural interface. That's a different conversation. So we have all these different sort of technologies. Now, when we actually have a look at the world in 2080, the things that we are building for, bearing in mind some of the platforms and assets that we're building today could still very well be alive and well in the year 2080. We have the concept of Category 6 hurricanes. In the US and Japan, both governments are now starting to think about putting in a classification for Category 6 hurricanes because we are seeing hurricanes at the top of the Beaufort scale. That fundamentally changes building regulations. The world will potentially be 5.4 degrees Celsius warmer. So over in Dubai, basically, where we all do a lot of building at the moment, when it hits 40 to 50 degrees Celsius, all the Emiratis leave for London. Now, if you think about the concrete cities that we have, that ends up being a heat trap. We have 3 foot's worth of sea level rise. That affects over 1 billion people in 54 megacities. What happens to the future of infrastructure in Louisiana or Shanghai, basically, when those are underwater? They need to be resilient. We have 10 billion people on the planet. We have 83 million deaths from heat. And we have up to 2 billion climate refugees. So you built your pretty thing. It's very livable, looks lovely. But frankly, it's either too hot or it's underwater, basically, now everyone's moved. You know, when we have a look at Jakarta, Jakarta is moving their capital city 100 miles inland, along with 12 million people, because Jakarta is not only sinking, it's flooding. Now, according to estimates, in order to make our infrastructure climate resilient, over the next 10 years, and this is 10 years, we need to be spending between $57 to $95 trillion. Now, at the moment, basically, we're spending about $3 trillion basically on climate relief. We're nowhere near these levels. However, when we start having a look at buildings, on the one hand, basically, they need to be resilient. So we actually have some interesting architecture already, basically, where the buildings are designed to flood. One day you can use them, next day they flood, and you can use them for something else. However, when we actually have a look at cryptocurrencies, over in Miami, we have infrastructure that is mining its own cryptocurrency because we have apps on citizen smartphones, but we also have supercomputers essentially within buildings, massive GPUs, BIM systems, climate change systems, etc. Now, when we actually have a look at crypto, over in Miami and New York are now doing this. These infrastructure developments, as well as basically their general population, have managed to raise over $100 million basically in crypto mining, which they can then use to fund infrastructure projects. So in Miami, when they hit $400 million mined from crypto, they will be able to go to their populace and say, you don't need to pay us any taxes. And this is what the mayor has officially said. You don't need to pay us any taxes, but we are still going to be able to fund infrastructure. But you can raise capital for your new infrastructure without going to a bank. So when we talk about NEOM, for example, they're now starting to embed these kinds of technologies basically into their $500 billion smart city. Similarly, basically, when we actually have a look at the future of infrastructure, you also have to look at the future of life, work, and services. So everything is decentralized, increasingly. So, for example, I could be a patient here in Guy's and St. Thomas Hospital. I might need a heart operation. But using teleoperations, robotics, and 5G, the person who operates on me can be in Mumbai because we have low latency telerobotics. That changes how you build a hospital. And that's now. That's not 60 years in the future. But when we start talking about future-ready infrastructure, we have airports, but we have the development of hypersonic aircraft. In fact, we have the development of hypersonic aircraft that can travel at Mach 17 using oblique detonation engines. We have new alloys and all kinds of crazy things, and these are topics in themselves. Urban air mobility vehicles, we have organizations like Radian One that are developing single stage to orbit spacecraft, like you see in sci-fi. There is no sci-fi movie basically where they go, we're going to launch a rocket, first stage away, second stage, off we go. That's it. It's all single stage to orbit. When we have a look at ports, so I did a lot of work with organizations like DP World, Abu Dhabi ports, and so on and so forth. This is where ports are not only fully autonomous, but they're integrated hubs. So DP World is actually investing in Hyperloop technology, which they're building in India, because from their perspective, they want to be able to move containers from Shanghai to the Middle East, to Rotterdam, at the speed of air freight for the cost of trucking. And then when we have a look at railways, yes, we have Hyperloops and maglevs. Now, when we start looking at HS2, 150 miles an hour? That's it. Standard Hyperloop, generally Mach 1. We're at about 350 miles an hour at the moment. Chinese are developing something called a T-flight Hyperloop, which is Mach 3.5. Now, when we start having a look at railways, for example, we have the development of a whole variety of other things, basically, and I can show you how we actually disrupt, basically, the railways. But when we have a look at roads, basically, we've got roads to buildings. So with Disney, basically, you take a fully autonomous car, you get into it, that car or that vehicle docks, basically, with a Disney hotel, and it becomes the actual hotel room. So new technologies, new transportation things let us do new things. When we have a look at unimodal transportation, I mean, why do I actually, to get here, why do I have to get in a car, walk, get in a train, walk, get in a car, whatever? Why don't we just leave here, essentially get in an Uber, and that single Uber, that pod, because we have the death of the car, why doesn't that just take us straight to where we want to go? Unimodal, not multimodal transportation. And then utilities are decentralized. I can extract water from air. Desalination technologies, basically, we've got single-step filtration systems. When we have a look at energy, basically, I can put decentralized solar panels, basically, on the roof here and decentralize your entire electricity company. I work with organizations like RWE and Centrica, and we're doing that. We're creating virtual power plants. We're not building actual power plants any longer, not really. If we have a flooding world, basically, then we also have ocean cities with companies like Oceanics, which are now approved by the United Nations. We have sea scrapers. So the type of things, basically, that we can build starts changing. These can mine their own resources, build themselves, and they can be self-generating. We have earth scrapers, which was a fun one that we did with Samsung. That's it. We can go up. Why can't we go down? Now, when we have a look at futuristic infrastructure itself, this is the Sand Babel. Basically, you might have seen it. Sort of came out 2018. Now, when we 3D print buildings, you can 3D print buildings in all kinds of different shapes and forms and formats and everything else. We no longer have to actually be rigid, basically, with our designs. But firstly, increasingly, when we have a look at things like parametric design, increasingly, communities and buildings are actually being designed by artificial intelligence. Now, in 2080, that will be an artificial superintelligence, basically, that has more collective wisdom and intelligence than the entire human race has ever had, which is saying something. So when we have a look at machines that can innovate, that's a whole conversation in itself. We already have machines that are designing products. Now, we can also start printing buildings, basically, in a single pass by swarms. But I haven't put robot swarms or drone swarms, because that's today's technology. Increasingly, they will change and transform as well. We also kind of have this funky vending machine sort of concept going on as well. Because one of the biggest problems that we actually have with today's infrastructure is its legacy. It's very difficult to upgrade. Now, when we start having a look at this, for example, we talk about 3D printing, 4D printing, where things self-assemble. We're doing that in space with organizations like NASA and SpaceX, where we simply 3D print a space station in low Earth orbit. But as I've demonstrated with organizations like Toyota, that's it. As well as University of Glasgow, you can grow things on site using molecular assemblers. But when we start talking about the materials and everything else, and we do this with the United States Department of Defense, if I'm here, if we talk about green construction, why do I have to bring all the materials to me? When we have a look at the space industry, when ESA goes to space and they build a village on the moon, they're not going, so what we want is a load of concrete and bricks, basically let's put that basically onto the Ariane space rocket, right? They're using the natural resources there. Another one of my clients, basically, is Majid Al Futtaim. Basically, we build typically master communities, basically about a quarter of the size of Paris. This is where we just look at using what is actually already there. So we take, for example, the earth that is already in Oman, and we just 3D print from that. But when you actually have a look at air, earth, and sea, for example, we can extract carbon dioxide, which you can turn into limestone or different kind of carbonates. You can mix basically with polymers and so on and so forth, basically on site. That's exactly what we're doing with the US DoD. You put a 3D printer in the middle of anywhere, it sucks out CO2 from the air, and it starts making a skeleton of whatever it is that you want. Now, when we start having a look at other materials, we've got green concrete, we've actually got carbon neutral concrete, we've also got carbon negative concrete already here. Some of it's in London, some of it's in the UK, in the US. So again, this is where we use carbon sequestration technologies to extract CO2 from the air, and we start using that as concrete filler. However, we've got graphene aerogels. Now, you might never have heard of a graphene aerogel, But a graphene aerogel, when it's 3D printed, is 10 times stronger than steel. But it is 99% lighter. We have living materials. So we literally have metabolizing living materials. So I could make my future buildings out of actual living materials that self-heal, regenerate, and all kinds of different things. Now, when we start talking about being able to, for example, either print a building or use a molecular assembler to build a building, this is where all the compute is integrated. Because by 2080, newer buildings can actually have biological artificial intelligence, biological compute, sensors built in. When we look at sensors, basically we have bio-optical sensors. If they were in the walls here and they detected the presence of COVID or pathogens, they would glow. So when we start having a look at how we can actually build or print or molecularly assemble a single building with everything that it needs built in, the electronics, the plumbing, basically the intelligence, the compute, there's a lot of things already here that allow us to do that today. Adaptable, reactive and programmable and tunable materials. When we have a look at things like metamaterials. Metamaterials, basically all of a sudden, one day, basically they can be soft. You apply basically an outside force, whatever that happens to be. It could be humidity, could be pressure, or whatever it happens to be, and then they harden. So when we start talking about climate resilient materials, for example, 1 minute it's flexible, but it ends up getting hit by a Category 6 hurricane, it becomes maybe more flexible. That's it. Or it just gets up and walks away. When we have a look at things like power storage and generation, if you put carbon nanotubes basically into concrete or red brick, they can store electricity. So again, with organizations like Centrica, as well as British Petroleum, the building is the battery. So we talk about grid scale storage. Your building is the battery, and your building is actually the virtual power plant, which then supplies electricity to the rest of the grid when it's needed. When we talk about energy generation, though, basically today solar panels are about 17% energy efficient. I can show you them in the labs, basically where they are 50 to 132% energy efficient. So when we're 3D printing a building or making a building, you just 3D print photovoltaic materials on the outside. Or you could use transparent solar materials, basically for glass. And these things automatically generate enough electricity for most of the city. So when we have a look at power storage and generation technologies in these buildings, there's a huge amount of stuff going on. Zero energy climate control, we have this today. You want to heat this building or cool this building using zero energy? Go to Stanford. In the day, the materials that this building are made of can absorb long-wave infrared light to heat it. But at night, it radiates short-wave infrared light out into space to automatically cool. So you can keep a building like this cooled at 74 degrees with zero energy. Now think basically that helps climate control. We've got DAC water, direct air capture water systems. Building like this, if I use something like a 3D printed heat exchanger on the roof, I can extract tens of thousands of liters of water directly from the Earth's atmosphere. We've done it. There's 2.4 zettabytes worth of active water basically in our atmosphere. And yet, by 2030, the United Nations says we are all going to fight over water. That's a different story. Dark water systems, when we have a look at single filtration systems, there is absolutely no reason today why, again, using things like graphene single-step filtration systems, you can't have a dark water system within a building that just never, ever needs replenishing. Because the filtration systems are literally that good. Food production facilities, vertical farms within buildings, bioreactors within buildings. You want to solve basically the problem that we have today. 1 billion people every day go hungry. You take the cell from an animal, put it into a bioreactor, you grow a chicken nugget, which you can buy in the US or you can buy in Singapore. That single technology solves global hunger for all of us. We've got printer to plate. I could incorporate 3D printers basically and all kinds of other things basically into these buildings. But again, we're beyond 3D printers by 2080. Dark operations, just as we see, ironically, basically with Ocado, basically we see Travis Kalanick investing basically in dark operations centers and dark warehouses and so on and so forth, dark restaurants. All of these buildings basically will be autonomously managed by artificial intelligence and won't need human input. programmable and robotic. When these things basically are programmable in whatever way you like, but you can just use your brain. In fact, these things basically know you better than you know yourselves. If you're flushed or stressed, basically, then they will adapt the building to you. Whole conversations in themselves. Modular and upgraded with thought commands. When we actually have a look at this, one of the biggest problems that we have with most buildings today basically is they are legacy. If you want to apply the latest technologies to a building like this, you kind of got to rip part of it down, refurb it. It's very expensive and everything else. Do you refurb it or do you knock it down? But if we have molecular assemblers, basically, and if you use a modular architectural approach, then we could just slide out that side of the building, recycle that, do whatever, and slide in a new one. But when we start talking about things like genetic engineering, I could literally just flick a switch and say, this side over here now has a different kind of bioelectronic environment. It now has a different kind of compute. It now has a different kind of sensor grid and network and all that kind of stuff. And then when I said about the era of massive organisms...
Sorry, can you... We're almost out of time.
That's it. We have synthetic biology. Nature does this all the time. They grow giant redwoods, basically, from a tiny little seed. So why can't we actually just grow a building, basically, from a seed? We already are laying the foundation for that. Using genetic engineering and synthetic biology, basically, we are now creating cells, basically, that can accommodate any kind of different shape, and we can program them. So we can say, these cells need to be triangular, and then they need to go together to create this kind of structure. By 2080, technically, you could probably plant an acorn, and it will just grow into whatever you want. And then as for where next, we've talked a lot about Earth. Realistically, basically, we're going to be doing stuff on Mars by that point as well. And that's me out. Thank you very much for listening. I hope you enjoyed that very fast-paced trip to the future.
Thank you, Matthew. I think, unfortunately, we're just about out of time, so I don't think we've really got time for any questions. So
That's good. Thank you.
Thank you.
Take care. Cheers.
Thank you.